welcome to online YouTube studying channel. I am Inaction Vincent, and today's topic is about electrostatics. It is lesson 2. A-levelers, those who are following me. Last week, you remember we looked at how an charged body can get attracted to the charged body. We also looked at the law of electrostatics, and we discussed a lot about electrostatics. So today it's just a continuation of where we stopped from last week. I am again Inaction Vincent, and my number is 0759746837. Follow up our YouTube channel, Homeline Studying YouTube channel, and you subscribe to it for you to always get videos. Now, without wasting much of our time, we are going to begin from a gold leaf electroscope. So this is not a new thing because you covered it in O-level. But for us in here, we shall be interested in actually two main parts. One part is called a glass cup. At times you can call it a metal cup. And another part is called a gold leaf. So these are two main parts that shall actually drive us throughout in this conversation that we are going to have today. So it has very many other parts, as you can see. It has an insulator. This is a glass rod. This is called a gold leaf. Then this is a glass plate or a metal plate. This is a metal case. You have a screen here, a metal screen or something, a glass screen. To those who have ever seen a gold leaf, so there is that glass there. So, but like I've told you, we shall focus so much on the brass cup, gold leaf, and the brass plate. Let us look at some of the uses of a gold leaf electroscope. Where do we use a gold leaf electroscope? One, we use a gold leaf electroscope to test the sign of a charge. We want to know whether the charge is positive or negative. We want to know whether the charge is, then next, to test the presence of a charge. Is the charge there or not? We want to know whether the charge is there. Then 3, to test the magnitude of the charge. So those are 3 main uses. There could be other uses, but those are the 3 main uses of a GLE or a gold leaf electroscope. 1, the sign. Is it positive or negative? 2, is it there? The presence of a charge is actually, is this body charged? And then 3, how big is the charge? The amount, the quantity of charge on the surface of the conductor. So those are the 3 uses. Now let us see, how can we test the sign of a charge? How can we know that this body is positively charged or this body is negatively charged using a gold leaf electroscope? It's a simple story. What we do, you give a gold leaf electroscope a known charge. For example, you can decide to charge a gold leaf either positively or negatively. Now you will bring a body whose charge is to be determined. You put it on the cap of the gold leaf electroscope. You note the divergence of the leaf. So we are saying that if the divergence of the leaf increases, if there is an increase in divergence of the leaf, then it will automatically imply that the charged body, I mean the body that you have brought on the cap, has a similar charge to that of the leaf. Then you will conclude and say, suppose you had charged the gold leaf electroscope positively, you will conclude and say, oh, even this body is positively charged. Suppose there is a decrease in the divergence of the leaf. If you bring that body whose charge is to be determined and you put it on the cap, and then you notice a decrease in the divergence of the leaf, then you come up with 2 conclusions. 1, you will say that, oh, that means that the body that I have brought either has a positive charge, an opposite charge to that of the gold leaf, or you will say that this body, maybe it is uncharged, or it is neutral. It's a neutral body. So the only sure test of the sign of a charge is when there is when there is an increase in divergence. So I think you've understood that. So an increase in divergence will automatically tell you that the body that you have brought must be having the same charge as that you gave a gold leaf electroscope. So that is one way of how you can test the sign of a charge of the sign on the body that you've brought on the gold leaf electroscope. Now let us also go ahead and look at how we can charge a gold leaf by a process called inaction. Remember last week we looked at how we said we have two methods of charging. We have charging by rubbing, we also have charging by induction. So let us see how we can charge a gold leaf by induction. So you can charge a gold leaf either positively or you can charge it negatively. I'm going to look at positively, then maybe you will look at negatively when you get time. 1, when you want to charge a gold leaf positively, you are going to bring a negatively charged rod. A negatively charged rod. You bring a negatively charged rod near the cup. Near the cup, this is the cup now of a gold leaf electroscope. Okay, this is our gold leaf electroscope. So you're going to bring a negatively charged rod near this cup. Now when you bring a negatively charged rod here, it is going to induce positive charges on the cup from the law of electrostatics. Positive charges here. Then negative charges shall be induced on the leaf and the plate. Positive charges are going to be induced here, whereas negative charges shall be induced on the plate and the leaf. Because we have a negative here and a negative, it will cause divergence. Therefore, the leaf will diverge. That is one step. Now, the second step, what we do, with the charged rod still in position, because remember we want to charge the whole thing positively. So with this negatively charged rod still in position, we are going to earth. I remember telling you that you can earth by touching. Once you touch, that means electrons will flow through your body to earth. So we are going to earth. You touch, that means these electrons, these negative charges will flow to earth. Now once they flow to earth, that means there is no charge here. But you remain with the positive charge on the cup. So you break the earthing. After breaking the earthing, you remove the charged rod. So once you remove the charged rod, that means we shall remain with something of this kind. You will have your positive charges here. So these positive charges will redistribute themselves on the plate and on the leaf. And therefore, divergence will occur. At this point, the gold leaf electroscope shall be positively charged. Even when a question comes and they say, how can you charge it negatively? This time around, you will bring a positively charged rod. Suppose they say, how can you charge it negatively? You will bring a positively charged rod. Now, when you bring a positively charged rod near the cup, that means negative charges shall be induced on the cup, whereas the positive charges shall be induced on the plate and the leaf. Because these are similar charges, there will be divergence. What do we do next, children? You earth. You earth by touching. This time around, since we have positive charges here, electrons will flow from the ground. Electrons will flow. They will come and neutralize the positive charges on the leaf and the plate. So then what you do, you break the earthing, because already now these charges will have been neutralized, there will be no charge. You break the earthing and then you remove the positively charged rod. So these negative charges on the cup will now redistribute themselves on the metal plate and the leaf. At the end of it all, the gold leaf will now be negatively charged. So children, that is how we can charge gold leaf electroscope positively and negatively by induction. So as you can see, the explanation highlighted. So I wish the cameraman can show you the explanation. The negatively charged rod is brought near the cup of the GLE. Positive charges are induced on the cup, while negative charges are induced on the leaf. Yes, as you can see, positive charges on the cup, negative charges on the leaf. Yes. So with the charged rod still in position, the gold leaf is then earthed. The electrons flow from the leaf and the plate to the earth, and thus the leaf collapses. The next thing you do, you just break the earthing and you take the charge drawn away, and then the positive charges shall distribute themselves along the sphere, along the gold leaf. So now let us look at how charges can be distributed on a pear-shaped conductor. Okay, so now members, that is how we can charge a gold leaf positively. Those are the steps that you should go through. There is a question here that describes how the gold leaf electroscope can be charged negatively by inaction. I have already explained that, so you just go through the same steps, only that where there is positive, you put negative. Now let us look at another term called charge density before we go to experiment to investigate distribution of a charge on a pear-shaped conductor. Now charge density, it is simply the quantity of a charge per unit surface area of the conductor. If I have my conductor like this, how many charges are here, how many charges are in this point, how many charges are in this point, is what we call charge density. In some books they even call it surface charge density. And this definition will be very, very important in as far as looking at this experiment to investigate the distribution of a charge on a pear-shaped conductor. When I talk about a pear-shaped conductor, it shouldn't actually disturb your mind so much. Look at any conductor which is not uniformly shaped. Look at a conductor that is not uniformly shaped. Maybe I'm talking about something of this kind. I'm just talking about something of this kind. Look at this conductor here, which is of that kind of shape. Which shape is this? So we shall simply call it a pear-shaped conductor. Now we are saying we want to look at that experiment to investigate the distribution of charges on a pear-shaped conductor. How are charges distributed on a conductor? What do? We get a proof plane. A proof plane, in simple terms, I will call it that device that we use to pick, because one, it generates charges, by the way, but it can also be in a position to pick charges and transfers it somewhere. So we are going to get a proof plane. I'm going to show you that from the diagrams that I'm going to use. So what we do, how do we explain it? What we do, we get our conductor. Maybe this is our conductor, our pear-shaped conductor. Remember, this conductor has these charges. I told you there are many charges on the sharp pointed end. So we are going to get our proof plane. Its role it is to pick sample charges. These are our proof plane. These are proof plane. So we get our proof plane. We get sample charge from here. So we are going to transfer the charge that we get into a metal hollow conductor. This is a metal hollow conductor. Metal hollow conductor, which is connected to the cap, of a gold leaf electroscope. This is our gold leaf electroscope. I'm just trying to explain how we can show that. Now, we are going to bring our proof plane and we input it inside a metal hollow conductor. So once you put it inside with these positive charges, that means it will induce negative charges inside. It will induce negative charges inside, then positive charges will be induced outside. I hope you understand that. Positive charges will be induced outside, and there will be now when you bring a proof plane with sample charges and you put it in here, you will note the divergence of the leaf. The leaf will diverge, okay? But then we are saying you keep on picking sample charges using a proof plane from different parts. You pick here, you bring it inside, and then you see how the leaf diverges. You bring a proof plane and you put it here, you take it back inside, you see the divergence. At the end of it all, it will be observed that the greatest divergence of the leaf shall be observed or shall be obtained when the proof plane was used to pick samples, or when the proof plane picked samples from the sharpest point. When you pick charges from here and you transfer it inside, the greatest diffraction shall be observed. What are we trying to explain? In other words, we are trying to say that charge tends to concentrate on the sharp pointed ends of any conductor. Therefore, that's why I'm saying that the proof plane is placed on the surface of the conductor, and then a sample of the charge acquired by the proof plane is then transferred to a hollow metal can, maybe call it a hollow metal can, which is placed on the cap of the neutral gold leaf. And then the diffraction of the leaf is noted. The proof plane is again used to pick samples or sample charges from different parts of the conductor. And each time, the diffraction of the leaf is noted. It is going to be found out that the greatest diffraction is always obtained when the sample charges are picked from the pointed end of the conductor. Therefore, it implies that there is a high charge density at the sharp ends of the conductor. Now, members, if you have a shape, for example, a shape like this, you will have, these are our charges, but more charges shall be concentrated at the sharp ends. More charges shall be concentrated at the sharp ends. More charges at the sharp ends. More charges at the sharp ends. That is the purpose of this experiment. If you have a conductor like this, let me just have maybe like that. More charges shall be here. That explains why a right-handed conductor is always sharply pointed. That means there will be a very high concentration of a charge. How about if I have a conductor like that? Is this a sharp? Is it having any kind of sharp pointed end? No. On such conductors, we shall have charges uniformly distributed. So meaning that from this experiment, it helps us to know and to conclude that indeed charges are highly concentrated at the sharp ends. Children, when we come back, we shall look at what we call Faraday's ice pail experiment. But remember, always subscribe to our channel and comment. I told you always have Zoom lessons on Tuesday and Thursday at 6 p.m. Endeavor to send me a WhatsApp so that I can send you a link, a WhatsApp message, and I send you a link. Remember, our YouTube channel is Homeline Studying YouTube channel for all O-level and A-level subjects. So endeavor to subscribe to the channel for more videos and for more lessons. Please get in touch with us. I shall see you next time. Goodbye.